Okay, so this is video 34, and this is mostly you just getting to play with this stuff. Okay, so I'm not going to do any of the exercises on this sheet, but I'm going to do something similar so that you can just get a sense for the kinds of things you might want to do. So I first have to give you a definition. What is a slope field? Okay, so a slope field is what happens when you sort of sketch usually an x and y or x and t plane, and then you're given something, let's say y prime is equal to x plus y. I just totally made that up. So the derivative is going to be when you're going to ask yourself, like, where is y prime equal to 0? That's usually useful, and that's going to happen when y is equal to minus x, because you just kind of solve this thing for 0 and figure that out. Just sort of play with this. So at y equals negative x, you're going to have a slope field like, you can have little horizontal lines. Now some people draw them with little arrows on them like this, but you know everything's always moving to the right, so you really don't have to put all the arrows. But anyway, if you're a computer, it's not that much effort, right? Okay, then when is this going to be, say, 1? When is this going to be equal to 1? Well, x plus y equals 1 when y equals negative x plus 1. Same kind of slope we're talking about, like y equals slope of this line we're speaking of. This line is negative 1, but it starts up here. So we're going to kind of think along a line like this. We're going to draw little 45-degree marks to try to remind us. I'm having trouble doing that, but pretend those are all at 45 degrees. And then when would this be equal to negative 1? So x plus y equals negative 1 when y equals minus x minus 1. So you shouldn't be too shocked that along this line we would have the behavior that it's going downwards. So this is kind of weird because the line itself that we're drawing the 45-degree angle markings on is also at 45 degrees. So this tells you something about what's going on in the phase plane, or in this slope field here, what's going on. So if I asked you, for example, to, well, let's just continue thinking about what's happening here. So as I get further out in this direction, the curves, whatever solutions I have, are going to slope upwards like so. All right? And this probably comes down from here and then slopes up. What happens down here? I think I have to investigate that a little more. So let me see. I would be thinking in terms of, you know, a slope that's even more steeply downward. So y is equal to, y prime is negative 10. What would that look like? So negative 10 is x plus y. Let me just figure that out. So to get negative x minus 10, it would be somewhere down here. Okay, I would have like very negative slopes, very steep downward slopes. So it looks like these things are going to pull. If we have a curve that's coming from the bottom side of here, it's going to probably look like it's diving straight down. I'm having a hard time drawing this. It would keep going down kind of like so. Okay, so that's my guess. So I just made up a question and then decided to play with it to get a guess as to what's going on here. And now what I'm going to do is I'm going to turn to a couple pieces of technology and show you a couple things I like and don't like on the internet in terms of tools. Okay, this is my typical first go-to, but I just want to say I don't find this very satisfying. It's okay, but I don't love it. This is not doing too bad of a job on this exercise. You can also just ask Wolfram to go ahead and solve this if you want. I don't think it's going to be that illuminating for you, but you can go ahead and ask it what's going on. Sure, that could be helpful. Okay, next example. Oh, in fact, this is the default sample on GeoGebra. I didn't even realize that. But GeoGebra is not bad. Okay, what you do is you have to change the function in here, your x and y relationship. Okay. Okay, Desmos is not a bad choice. I think you can pull it around, I guess. This is kind of interesting. I've never played with this before. That's kind of fun. Okay. I don't know if it lets you create a solution from a point. That would be fun. I don't know if it does or not. Here's another tool. Again, it's using x plus y as the default. And you would change your function here. Be careful, some of them are y and t, some of them are x and y, but you know, no big deal. And as far as low-tech, high-tech, I think I like this one best, at least some of the things I've tried. So let me just go ahead and try t plus y here and see what happens, and then I have to generate it. I don't know why, but this just strikes me as very elegant. I like this. So there you go. There's some pictures for you. And let's try another example. Okay, and this particular type of exercise seems to really cause problems for most of those plotters I just showed you, and I'm just going to show you that sometimes you do a better job understanding what's going on by hand. Even though Wolfram Alpha will solve this for you, and it's a complete gobbledygook mess. So when x is equal to 0 or y equals 0, so like on those two axes, then we have a horizontal slope. And whenever, let's say, y is equal to 5 or x equals 5, so let's just estimate that that's where they are, you're also going to have horizontals. So what's going to happen when you are between x equals 0 and x equals 5, x is negative, right? And when you're between y equals 0 and y equals 5, that's negative, so net positive, because negative times negative is a positive. You can do this same analysis in each of the other 8 regions, and you find out that you're going to get a positive slope in 5 of those boxes, and you're going to get a negative slope in 4 of those boxes. Now, most of the plotters will just give you vertical lines because it's like, oh, it's really, really steep. Well, I don't care that it's really, really steep. I actually want to know if it's increasing or decreasing. And you plotting, you meaning the plotter, plotting this stupid vertical line gives me 0 information. So I don't care if the slope is right. I just want to get some sense of what the solution curves can do here. And for example, this tells me that it's possible to cross this threshold. I don't know, you know, what exactly the solution curves are going to look like, and it could cross this threshold this way, right? But it means I can't cross this way, right? I can't do that because I am eventually going to go to a slope of 0, and I might shoot off to infinity. But once I kind of suck into this line that's supposed to be horizontal, it should go on that way forever, right? And this line, well, this is an unstable line, but you might just get sucked in and stay there. It's not clear. And a lot of these things maybe have a mathematical answer, but maybe not an engineering answer. These are very fascinating things. So you might expect a solution curve to do something like that, or you might expect a solution curve to do something like this. Okay? So it's things to think about, and I'm just going to go ahead and pull up that last one we just had and say what's going on here. If I say y minus 5, t minus 5, and of the different plotters, this one did the best. Maybe I need multiply inside here. It did a good job last time I tried. Okay, it needed the multipliers, but see, it's also only going to wherever I ask it to go. So I'm gonna move these around. Since I know my roots are at 0 and 5, I'm just gonna go a little bit outside there so I can get a sense of this. just get a slightly better picture. You can change these up however you want. I would like to kind of write on this. Okay, hopefully this will work. I opened up Zoom just so I could write on here. But this sort of shows you where 5 should be. This should be a line that you can't pass. And then this here, there should be a line that you can't pass. And that's why the arrows flip on that line. They go from going down on this side to going up on this side. Okay? And so even this, which is like my favorite of these guys, it's not clear what could happen. And for example, it's not clear if you enter here, if you're going to exit here, or you're going to go this way. One of those two things will happen. I'm going to bet that you're probably going to go like that, but I'm not 100% sure. And again, if this is an engineering question rather than a pure math question, it may be very possible for particles to cross over at this point, because maybe you've got something happening out in the ocean and particles can cross over there. So all sorts of interesting questions. So the point is, the reason for doing, say, this exercise is to remind you that the technology has limits. You have plenty of information now to do the worksheet, use your own intuition, and also use the technology and enjoy it.